how this is going to kind of work, we'll do 1-1 to 1-3. We'll test over that, and then we'll kind of just spend a few days on 1-4 to 1-5, and then what you'll end up getting is going to be like basically just a take-home quiz over those two sections, just for what it is and not really the amount of content in there, and it's really just going to be about 3 or 4 days. If you've looked at the calendar, 3 or 4 days of just really work time and things like that, because it's not it's a lot of review from there. And then I'll put up it'll be online. It'll just be an online quiz. It'll be open note, open person. You can work together, whatever. Okay, so, but it'll just be taken as a quiz, so that'll hopefully help you with things there. A lot of what's in the first 3 sections, to be honest with you, today and tomorrow are 1-1 and 1-2, and they're going to be pretty straightforward and pretty easy, because like today is really just about graphs and graph utilities. So basically, like if you have a graphing calculator, as far as what you're going to look for, so anytime you have a graphing equation and you're creating tables using a graphing utility, basically a graphing calculator, you can obviously use like Desmos or things like that. Graphing calculator is one that you're going to be able to use on the test. Basically, we talk about like the viewing window and like the viewing rectangle. Basically, that's just the space within your calculator. So what you're actually looking at is and I've got the TI-84 here with everything. Whenever you talk about like the window and stuff of that nature, it's basically like, what do my values go to as far as my X values? What's my low number? What's my high number? What's my low number for my Y and my low number for my X? Okay. The easiest way to get to your graphing window is just going to be to click the window button, and it's going to tell you everything that you have. So like that it goes from, your X-axis goes from -10 to +10, and that we're counting by ones. So if we go to a graph, that each basically little tick mark that we have here is a single. Okay, it's 1. We can change the window regardless. Like we can still go from -10 to 10, and we can count by 2s instead. Okay, the only thing, the graph isn't going to change, but like the values here will. Okay, is all it really does. Okay, you can do the same thing for the Y. So like whenever we talk about the window and your X values, we talk about the X minimum and the maximum, and then whatever your scale is. The default scale of any of this is really just -10, -10 to 10. But this is your standard scale from -10 to +10, and then 1 is just being your scale. That's just the distance between every tick mark, like we said earlier. You know, a lot of this, like whenever we talk about intercepts, remember that whenever we talk about an x-intercept, that means your y value is 0. Whenever we talk about a y-intercept, that means your x value is 0. So if, you know, like in this case with a parabola, you have your intercepts here that you can see obviously on the graph, and, you know, whoop, wrong thing. Like there's your y-intercept, and then you have 2 x-intercepts. Anytime, like if you have like with your graphing calculator, if you're not sure, okay, so I have my graph. I can go to second and calculate, and I can see where my zeros are. Anytime it asks for a 0, okay, so like it asks for a 0 here, it's going to ask for like a left bound, right bound. So zeros talk about my x-intercepts. So if I zoom out, instead of, so you can actually see. So I need to be basically on the left side of one of my intersects. So it's just I'm just gonna arrow over until I'm on the left side. Okay. Obviously I can see that it's probably going to be at -3, but I want to make sure that I'm on the left side, then I'm on the right side. What should happen is you should get 2 lines. Okay. If you have like an 83 or older, then it's just going to have the arrows and it's not going to give you the lines that you have. Okay. If you use like Desmos or things like that, it will like put the point on there for you. Okay, if you use that as far as your graphing utility. As far as the TI-83 and 84 and anything like that, it's going to draw those lines and it's going to ask you to guess, which, yes, I want it to guess, and it's going to give you that 0. Okay, you can trace really anything and just arrow over and it's going to take it to a certain extent. It's going to go up by that or move over by that 0.1515 or whatever. You can change that if you want. Like you can change it to where you move every half step. And then as I go, it may or may not. So as we do this, you know, if you're just going to trace is never going to always give you a point. Like if I continue to arrow over, it may not give you a spot where your y is at 0 and your x is at 3. Okay, you may have to go to second and trace or calculate, so then you can go from there. A lot of this, if you don't know, you can find your minimum values and your maximum values as far as like where it curves and where your various, like in this case, like where your vertex would be. Even if we go to 5, you know, where if anything intersects, now we only have one curve, so we're not going to have any sort of intersection. But say if we drew a line or we had like a straight line, you could figure out where they actually intersect. Okay, so it knows where your first and your second curves are. But there's a lot of things that you can do with this that will definitely help in the long run. You know, identifying the x and the y intercepts. In some cases, you may only have one intercept. You know, like in the first case, you have an x-intercept and then you have a y-intercept. Okay, you can plug values in. Just plug your x or 0 in for x if it's an x-intercept or y-intercept, and then vice versa for the x-intercept. Okay, in some cases, like we said, like on the second one, you don't have a y-intercept. It's just a vertical line. Okay, and then in some cases they may be at the same point. It may be at 0, 0. It may run through the origin. Okay, then is it possible that a graph may have no intercepts? You bet. Okay, you probably dealt with it a lot in Algebra 2 whenever you were dealing, especially with like quadratics, whenever you had imaginary solutions. If you had to actually solve, because you solve for x-intercepts or solutions or zeros, whatever, there may have been times that you didn't cross the x-axis or you didn't have a solution. Okay, that's okay. You can still have times where you don't have an x-intercept or you only have one y-intercept. Okay, there may be times, depending on the graph, okay, not necessarily it being a function, but a graph where you have multiple intercepts, okay, where you have some and there's one that's not drawn, that it may be a cubing function, that it looks something like this, okay, where you have similar to like this graph here, but we have multiple x-intercepts and then we have a y-intercept here. Okay, there are various things that can happen that you can have multiple intercepts depending on the function or depending on the graph, along with having absolutely no no outcomes as far as intercepts are concerned as well. Interpreting information whenever you're given by graphs. So if you have a line graph that are often used to illustrate trends over time, now it's not like a true line graph because it looks like it has a little bit of kind of a curve. I guess it really goes, it's linear from certain points. So it says divorce rates are considerably higher for couples who marry in their teens. Line graph in the figure show a percentage of marriages ending in divorce based on the wife's age at marriage. So you have two different lines depending on what you have. Okay, kind of your two different scenarios. So you have whenever the wife is under 18 at the time of marriage, and then when the wife is over 25 at the time of marriage. So there's kind of that gap as far as, you know, the one on top with, it's, I'm going to call it red or purple, and then the one that's blue on the bottom side. So it says use the appropriate formula to determine the percentage of marriages ending in divorce after 10 years when the wife is over 25 at the time. So at the time of marriage. So basically, whenever we go to our graph, which one are we going to use? Are we going to use the top one or are we going to use the bottom one? Which graph are we actually going to look at? If we're dealing with wife's over 25, the bottom one, right? Or the blue one, whatever you want to call it. So the blue one here, 10 years of marriage, what's the chance that, or what's the percentage that there's going to be a divorce? Well, 10 years, we went up, we go over, so 25% chance. Okay. Basically just using the information that you have, okay, reading the question and going from there. Alright. Same way, use the same graph to determine the percentage of marriages ending in divorce after 1 year when the wife is over 25 at the time of marriage. So, same line. Okay. Now, in this case, we don't have an actual value for 1 year. We have for 5. So we may not be able to use the graph. You can probably guess or have a pretty decent idea. Okay? But if I use the actual function, so n is the number of years, right? So which of the two formulas am I going to use? Am I going to use the one on the left or the one on the right? 25 years, 1 year of marriage. What's the chance of them getting divorced? Or what's the percentage? Am I going to use the one on the left or the one on the right? One on the right. What number am I going to plug in for n? How many years have they been married? No. Second question. So after 1 year, so aren't I just going to go 2.3 times 1 plus 1.5? So whenever I do that, 2.3 plus 1.5, so I've got about a 3.8% chance of them getting a divorce.